2, 1. Main engine start, 0. And liftoff of the Atlas V with Curiosity, seeking clues to the planetary puzzle about life on Mars.
We understand that there was water sort of in Mars's early history, but then as you go sort of from the start of the Hesperian, so 3.7 billion years ago, towards 3 billion years ago, Mars dried out. And that's round about the same time that life evolved on Earth. And we think that's round about the same time that life could have existed on Mars as well. And what we found by looking at these rocks is that there was abundant water on the surface of Mars much later than we expected. We have this sandstone which represents migrating dunes deposited onto the side of it. So they must be the youngest thing, or one of the youngest things in the crater. Within that sandstone, we find these structures which cross-cut them, which are evidence of water. So they must be one of the youngest things to happen in the crater, which therefore means we have these structures which were formed by water are one of the latest things in the crater. Therefore, there must have been water more recently within the crater than we previously thought. If we go right back to Earth's early history and Mars's early history, and we start the formation of the planet, and then we sort of move forward in time, we know that life took time to sort of evolve and be established or become established. And at that point in Earth's history, we have life, but it might not be able to leave any evidence in the rock record. It needs to evolve and become more complicated before it can leave an impression, either through chemistry or through being able to stick sediment together to be able to leave an impression in the rock record. Similar conditions existed on Mars at the same time as that on Earth, and it would be reasonable to believe that life would potentially evolve on Mars, but then it would need more time to sort of evolve into a state where it could leave a impression in the rock record. And by us identifying this water later in Gale craters, infill in history, it pushes back that window where the opportunity that life could evolve and be preserved in the rock record. Mars started losing its atmosphere and it started drying out. So all of this water that was on the surface began to sort of boil off and was lost into the atmosphere and then into space. So between 3.7 and 3 billion years, Mars essentially lost all its surface water, or most of its surface water and most of its atmosphere, which is the same time that we were hoping life may be evolving. So on Earth, conditions remained favourable for life up until round about now. But on Mars, conditions started drying out, and life on Mars was definitely against the clock to evolve before conditions on the surface became uninhabitable.